Good morning, children. Mona Chimso, how are you today? Kimberly, hope you are keeping safe. Macarius, I hope you are doing great. Christine, how are you doing? Rachel, how are you today? Alright, today's topic on squares is space facts. Space facts. Space is amazing, very big, along with trillions upon trillions of objects in the many billion galaxies. You know our star galaxies, the galaxies of the universe. The many billion galaxies of the universe is almost incomprehensible to the human brain. What is a space? The universe is the space. So the space simply means the universe, where you and I dwell. This universe is made up of the stars and planets, including our own Earth and Sun, and the space between them. It's far larger than we can ever imagine, very vast. Do you know neutron stars can spin at a rate of 600 rotations per second? Neutron stars are one of the possible evolutionary endpoints of high-mass stars that are born in a core collapse supernova star explosion and subsequently rotate extremely rapidly as a consequence of their physics. Neutron stars can rotate up to 60 times per second after burn. Under special circumstances, this rate can increase to more than 600 times per second. That is it. Look at the image. You can see a blue star. I've taught you how stars are formed. That a star is a ball of gas so hot that it burns and glows. That some stars range in temperature from 2100 degrees centigrade and about 50,000 degrees centigrade. That the color of a star is an indication of how hot it is. White stars are hotter than red stars, but some stars become even hotter and shine with a blue light. You can see the image. You can see a blue light. That is a hotter one. We discussed the birth of a star. I told you that stars start to form when a mass of gas and dust begins to pull in on itself by force of gravity. This gas heats up and begins to glow, begins to shine. The space is completely silent. Sound waves need a medium to travel through. Since there is no atmosphere in the vacuum of space, the realm between stars will always be always silent. That said, worlds with atmospheres and air pressure do allow sound to travel. Hence why there is plenty of noise on Earth and likely other planets as well, because there are atmospheres. So sound can travel. That is the image of a silent space, a silent zone. There is an uncountable number of stars in the known universe. We basically have no idea how many stars there are in the universe. Right now, we use our estimate of how many stars there are in our own galaxy, the Milky Way. We then multiply that number by the best guesstimate of the number of galaxies in the universe. After all that math, NASA can only confidently say that there are zillions of uncountable stars. A zillion is an uncountable amount. A zillion is an uncountable amount. That is our stars, uncountable. Can you count them? Monachim, can you count the stars? Can you imagine this? They are uncountable. You can also see a blue star, a glowing star. The Apollo astronauts' footprints on the moon will probably stay there for at least 100 million years. Since the moon doesn't have an atmosphere, there is no wind or water to erode or wash away the Apollo astronauts' mass on the moon. That means their footprints, rover prints, spaceship prints, and discarded materials will stay preserved on the moon for a very long time. They will stay on there forever though. The moon is still a dynamic environment. It's actually being constantly bombarded with micrometeorites, which means that erosion is still happening on the moon. Can you imagine that? Just very slowly. That is our astronauts, the Apollo astronauts that visited the moon. Can you see them? These are rovers, they are rover prints. They are going to remain there for about millions of years. Because the moon has no atmosphere, like our Earth that has a place that has an atmosphere. %99 of our solar system's mass is the sun. Our star, the sun, is so thin that it accounts for a whopping 99% of the mass of our entire solar system. That's what allows it to dominate all of the planets gravitationally. Yes. That was why when that spinning started, its weight, it was so deep. It was so heavy. As when I talk to the evolution of the solar system, I said gravitation fall upon a material on the supernova, and something began to happen. It began to spin at a very fast rate. As it was spinning, some of us were scattering. The scattered rods the scattered rods that were a bit bigger began to form the planet. The ones that are a bit smaller began to form the satellite. But the sun, a hot gas was seen doing this process of this spinning. Very hot. It was too hot that it could not spin as fast as other rods we are doing. That was why the sun settled at the middle of the solar system. It's not just there by scientific observation or invention. It was as a result of nature. Technically, our sun is a G-type main sequence star, which means that every second it fuses approximately 600 million tons of hydrogen to helium. It also converts about 4 million tons of matter to energy as a byproduct. When the sun dies, it will become a red giant and envelop the earth and everyone on it. But don't worry, that would happen for another 5 billion years. A G-type main sequence star is a star with a surface temperature of about 5,300 and 6,000 degrees. It's in the process of converting hydrogen to helium in its core by means of nuclear fission. Sun is in fact white but appears yellow through the Earth's atmosphere due to what we call Rayleigh scattering. I won't tell you what Rayleigh scattering is for now. I think curiosity should lead you to make a research on what I meant by Rayleigh scattering, being the reason why we see the sun as a yellow object on the sky, despite the fact that it's naturally white in color. Look at this. Can you imagine how hot this could be? Remember, we also said that a white star is hotter than a red one. Oh, don't forget. So when I look at this image, look at see this is raw, this is fire, this is fire. Look at how red it is. Look at how reddish it looks. But our sun is actually white in color. If two pieces of the same type of metal touch in space, they will bond and be permanently stuck together. This amazing effect is called cold welding. It happens because the atoms of the individual pieces of metal have no way of knowing that there are different pieces of metal, so the lumps join together. This wouldn't happen on Earth because there is air and water separating the pieces. Take a look at this. This is the cold welding. This is the cold welding. The largest asteroid in our solar system is a mammoth piece of space rock called Ceres. The asteroid, which is sometimes known as a dwarf planet, is almost 600 miles in diameter. It is by far the largest in the asteroid belt between Mars and Jupiter and accounts for a whole third of the belt's mass. Ceres' surface area is approximately equal to the land area of India or Argentina. Can you imagine? Take a look at this. The Ceres surface area. Say it is approximately equal to the land surface area of India or Argentina. That will be very large indeed. I won't quit this lesson without differentiating the other satellites for you. We have comets. A comet is a small satellite when close to the sun. When a comet is close to the sun, it displays a visible tail, though comet appears once every 72 years. Asteroids are made of rock and metal. They are smaller to comets. Meteors are smaller asteroids. That is, smaller asteroids are called a meteor. Take note, please. The meteor, a meteor that burns up as it passes through the Earth's atmosphere is a meteor that burns up as it passes through the Earth's atmosphere is known as a meteor. A meteor that burns up when it passes through the Earth's atmosphere is a meteor. If you have ever looked up at the sky at night and seen a shooting star, what you are seeing is a meteor. A meteorite is a meteor that survived falling through the Earth's atmosphere and colliding with the Earth's surface. I hope you enjoyed your lesson. Now pick up a pen and paper and take down my question. Number 1. What is a space? 2. Discuss how stars are formed. 3. Are you there? Monachim, are you writing? Kimberly, are you writing? Alright. 3. State 3 facts about space. State 3 facts about space. 4. Discuss the G-type main sequence star. Discuss the G-type main sequence star. Remember, the sun is an example of a G-type main sequence star. Very hot. That is why many are saying that what is killing the Earth is a G5 mass, not coronavirus. Imagine when you say that a surface temperature of this G-type main sequence star is 5,300 and is between 5,300 and 6,000. You can imagine what that means. Right, take your question. Please ensure you copy your notes correctly and attempt the questions that have been given to you. Be good. I'll see you some other time. Bye.